Hello, today we are going to compare the C++ programming language integrated development environments, JetBrains CLion, and Qt Creator. These are their official web pages. I'm going to install both, and the way I'm going to install it, I'm going to use the JetBrains toolbox and the Qt online installer. So we're going to install Qt Creator. We search for the Qt Framework's official website, which is www.qt.io. Download try on the up right bottom. And then let's search in here, community user. Scroll down. Download the Qt online installer. And I'm on a Linux operating system, Ubuntu 24.04. So this is the package for me, Linux x64. And now it says Qt Online Installer for Linux 64-bit. So this is a, I have downloaded this file, and the file has the extension run. If we're going to look at the file, using, for instance, the Unix command line file, it's going to say that it's a Linux 64-bit ELF file, which means that it's an executable and the default binary format for Linux. In order to actually run it, it must have the X chmod bit set. This is the way I did it. So right click on the file, properties, permissions, and then I'm checking the checkbox is executable. OK. And now we can just double click on it. This is the way it looks like. It requires that you create an online account on the website www.qt.io, which I have. And then you go next. I have read, I do not use Qt for any company. And then you select the directory where software installed using Qt Online Installer will be installed. The default is ~/Qt with an uppercase Q. That's a good enough directory. And then you're probably going to go with custom installation. And then from the list, you should select at least the integrated development environment Qt Creator, the latest stable version. And then you go next, and you close the wizard. The Qt Creator integrated development environment will be installed. And then the next time you want to install an update to Qt Creator, or you want to install more software using the Qt Online installer, you can find a graphical user interface application in your start menu, which is called Qt Maintenance Tool. Very similar to the Qt Online installer, looks like this. And here the options are to install more components or to update the existing components. I'm not sure why these radio buttons exist in here. They're totally not intuitive. Okay, let's look at what's possible to install using the Qt Online installer. This is a Qt Design Studio. This is a tool for designers, not for developers. It's for creating mockups. It's for 3D animations. I'm not exactly sure what it is. I have never used it. I do not use such a thing. So I'm a developer. I'm not a designer. Next up, under Qt, Developer and Designer Tools, you have the latest stable version released of Qt Creator. So in this case, it's Qt Creator 14.0.1 to make sure this checkbox is enabled. Optionally, you might want to also install the Qt framework if you want. In my case, I must install it because my Linux operating system has a really old Qt 6 version. I'm on Ubuntu 24.04. But most of the time when you're just working on C++ projects, you're not actually developing Qt projects, you would not need to install Qt. So you just go straight for Qt Creator 14.0.1 under the Qt and then developer and designer tools. The Qt maintenance tool is this graphical user interface application that you see here, and this is mandatory. You cannot uncheck it. It will be installed. And like this, Qt Creator is now installed on my computer, and you can find it in your start menu if you write, for instance, parts of the graphical user interface application name. So Qt Creator, you can go CRE and press enter. Let's now install the JetBrains CLion integrated development environment for C++. I'm searching for JetBrains toolbox. Let's see which one of these is. So it's a graphical user interface application from JetBrains, the makers of the integrated development environments in the family of CLion and IntelliJ IDEA and PyCharm, etc. And this is a centralized application which allows you to install the newest version of many of the graphical user interface tools from JetBrains, all of their integrated development environments. It allows you to upgrade, to install updates on those applications or to install older versions. You can see at a glance what are all of the applications that you can install on your operating system. You can see which ones require a license, which one are free, etc. The option here is just one, a tar.gz file, because I'm on Linux. So let's do that. Let's look at the application. So it's a tar.gz. You need to extract it. You can extract it like this, for instance. So tar.gz is a Linux archive. GZ means that it's compressed using the GNU zip compression algorithm, and then tar means that there's a directory structure which is turned into a single file with extension tar. Inside there's a single file which you don't need to set the chmod bit executable. It's already set for you. So this is the actual difference between these two executables. This one is delivered as just the executable, and you need to set the chmod bit executable yourself and then run it, whereas this one is served as an archive, and since it's an archive, it has the correct chmod bit set correctly for you. You just need to extract. So in here you need to go properties and set the chmod bit. In here you need to extract. There's still a need for an additional step from the user. You cannot just download and then run by double-clicking. Let's see how this thing looks like. Let's also use file on it. The same thing, ELF 64-bit, so a Linux native executable for AMD 74ff5246. So that means that it's probably a graphical user interface application and you can just double click on it. Probably not. So it might be a console application. Let's open a terminal in here. No, it was actually a graphical user interface application. Okay, it just installed without asking anything. Great. But then it didn't have a splash screen such that you know that you need to not click on this application again, or that you need to wait for a millisecond. This is how the application looks like. The application has a tray icon, and its functionality is to list all of the possible applications that can be installed on your operating system, and then has install button. So it's similar to an app store from JetBrains. The gratis applications that you can install from here are PyCharm Community for Python programming language, IntelliJ IDEA Community Edition for Java, Android Studio for Android applications, and then some applications which are being developed. Maybe they were not yet publicly released, and you're using them as a way to help the development and as a way for you to test the application before release. So a way in which the end users can help the JetBrains company. So I have CLion installed. CLion will be listed in here, and you click on the install button. That's all you need to do. Very simple. That's great. And you can install different versions, and you can uninstall the application, and you can also start the application. Just double click on it and it will open. The application is also available in the start menu, so it's as CLion. Okay, so now we have the two applications installed. How do we exit this thing? We're going to exemplify how to use the two integrated development environments for C++ using the KD communities application Juke. This is a audio player. I have built it using the default KD meta build tool, which is called kdesrc-build. This is the command line. So Juke has been built correctly. Yeah, let's now run it to see if it runs correctly. Okay, so we can see that the application has started. It has found the three audio files that I have available, and playback also works. There is this slider for the playback position. There's buttons for advancing to the next audio file. Let's hide the lyrics tool window. So this is it, a audio playing application. Has playlists. The playlist is the center of the application. There's progress. There's the file length. Let's now do the similar thing that we did using the command line kdesrc-build Juke, which builds and installs the application, and then us running source and then Juke, which runs the application. Let's do the similar thing in the two integrated development environments. I have my notes, my instructions on how to use the two integrated development environments together with kdesrc-build. This is my wiki and mariusp.github.io. And at the end of this page, there's the instructions. So we'll start with Qt Creator first. In here it says how you can install the application, hopefully. And I'm recommending that you use the Qt Online installer. You can set the chmod executable bit from the command line. If you install from your Linux binary packages, then Qt Creator might be either incomplete, maybe some plugin is missing, so not the way that the Qt community has intended to ship Qt Creator, or it might be an older version. It's better if you respect the upstream. The Qt framework is producing Qt Creator, install it from them, then it's clear where you can report bugs if you have issues. You just go straight to the source of the executable. Okay. So we've built an application using kdesrc-build. In our case, it's Juke, not Calc. Calc is a desktop computer calculator. It looks like this. So we need to start from the application launcher Qt Creator. Let's make it use half of the screen. File, open file or project, and in here we'll try to paste the correct path. So that's ~kdesrc Juke and the CMake lists file. Let's copy the full path, Ctrl-Alt-C, Ctrl-V. And in here, everything's complex and confusing. The functionality is there in Qt Creator, but you need to follow some additional steps. So let's see. We go, it already switched to the projects. So in the left sidebar, there's ways of navigating to different areas of the integrated development environment Qt Creator. This is the welcome screen. This is the text editor with a view of the project. I'm not sure what happened in here. One file or project, okay. We were here in the tool window, switch to projects mode, Ctrl-5. And in here we go manage kits. We should have the Qt kit that I want to use. So a kit is a combination of shared libraries, SO files, header files, .h files, so include files, linker, compiler, all of the toolset that's needed in order to build, in our case, Qt applications. So I'm using Qt 6.8.0, which was installed using the Qt Online installer. So this is the actual kit that I'm using. So in here in Manage Kits, if we have more than, I don't know, 10 kits, we should delete the ones which are temporary. Nothing, we don't need to do anything yet because there's no inflation of kits. Okay. And then we go import existing build. And the build directory is the same directory, but we swap src with build. did we do? And without CMake list, so just the path to the directory where CMake has generated its files. kdesrc-build uses CMake, the KD Git repositories do use CMake. Okay, and now we have an additional build configuration which is named debug2. This is what we're going to use. It has already selected the correct kit because I've used kdesrc-build. This has used CMake, and CMake was told, hey, please use Qt 6.8.0, which was installed using Qt Online Installer. So when in Qt Creator Integrated Development Environment, we're importing the existing build, which was created by CMake, which was created by kdesrc-build. In there, in this build directory, it's already written down that the Qt that we should use is the 6.8.0 version you installed using Qt Online Installer in ~/Qt directory with an uppercase Q. Okay, so it has imported the most important settings from the already existing CMake build directory. Let's see if we need to do something else. We might want to set some environment variables, but the environment variables are for QML and Qt plugins, so I guess that we can skip setting these environment variables. But if you have a QML application, not just a Qt widgets application, then you need to follow this step. Okay, so this should be it. Let's look at the inside of this button, which is the button which allows you to select the current project. That we want the debug to build configuration to be the one that's used when we build, run, or debug this application. And then we want that the executable that started when we debug or run the application should be Juke, which is a graphical user interface application, not debugger set test, which is a command line Qt test, ctest executable. So this has already been selected correctly for me. All that remains now is to run the CMake configure step, which has also been run automatically for me. Let's see where we can run the CMake configure step once again. Build. Let's see. So we arrived here. From build, run CMake. Which one? This guy. I'll look a bit at the CMake configure steps to see if everything's exactly as I wanted. So source directory, build directory, correct. The correct Qt version has been found, which is 6.8. The KDE frameworks version 6 have already been built as build dependencies by kdesrc-build. When I said kdesrc-build, please build the KDE Git repository Juke, it has built all of the other KDE Git repositories which are dependencies of the KDE Git repository Juke. So kcrash, kglobal Excel, kicon themes, etc. And then it has found all of the needed Qt modules, all of the needed KDE dependencies, but it has also found third-party dependencies, so other packages that I have installed on my Linux machine which have nothing to do with Qt or with KDE, such as this one, taglib. Okay. Next up, we can tell CMake to build, to compile and generate the executables, the shared libraries, manual page, etc. This is that step. So build project juk. Let's see how building works. The tool window, compile output Alt4. So this is the output from CMake. The command line was CMake. It's using the CMake from my Linux operating system, not one which is shipped by Qt Creator or from the Qt Online installer. The command line is build, and then it says the directory where the CMake build directory is, and then as target it builds all of the targets. Then CMake is using Ninja. There's Ninja files already existing in this directory, which were created by the previous step, the CMake configure step. The C++ compiler is showing build warnings. There's other tools being run in here, not only the C++ compiler and the other C++ toolchain executables, the linker, the C preprocessor, etc. But also this step, which is generating translation files using probably GNU gettext. The linker, there's two executables being linked, the ctest, qt-test command line executable tagger set test, and the graphical user interface application which uses Qt widgets named juk, the audio player. Okay, at this step we can see if the application starts correctly. We didn't do additional configurations, which implies setting environment variables neither for the CMake configure step nor for the Qt Creator run or Qt Creator debug step. So let's go through the Qt Creator run step. So this button run Ctrl R, and the application starts, but it doesn't start correctly enough. The procedure says that you should set these environment variables as part of the before doing the CMake configure step, and then you need to set additional environment variables before the run step. Let's see where that is documented. In here. So configure run settings in the build and run section of the projects page. So this is a projects page, build and run this, and then run, and then in here, let's press the escape button to close some of the tool windows. Okay. Run settings, where are those? Run. The graphical user interface of the Qt Creator application keeps changing a bit each time, but this means that the instructions that I have get outdated. Again, you're using the latest and greatest version of the integrated development environments by downloading from their upstream official websites. And then you're also using graphical user interface applications which make sure that the integrated development environments are up to date. So the Qt toolbox from the JetBrains company will help you make sure that CLion is always up to date, and the Qt maintenance tool makes sure that Qt Creator is always up to date. But both of these applications require manual intervention. So they will notify you, hey, there's an update, but you need to acknowledge and accept to install the update. So nothing's automatic. So this part, run settings and then run configuration, is this one, run and run configuration. It says that we should select the correct CMake target, which we did, which is in this case has been set correctly by default. So Juke, the main executable, not other ctest CMake targets. And then inside of the environment section, this guy, there's a details button. And in here, we have use build environment. And we want to add additional environment variables in here. If this button is enabled, then there are some customizations, some environment variables entered in this list view. So we should press the reset button. In this case, it's disabled because this list view is empty. And then we want to paste the environment that is specified in here. So let's actually look at that. So before running Juke from the command line, we have set some environment variables from this file. These are the environment variables. This we'll need to configure also before running in Qt Creator the application Juke. Otherwise, for instance, in this case, KIO will not work. And that's probably because of this environment variable. So let's see how we do that. Let's do it by involving the command line shell, which in my case is bash. These are not setting anything, they're commented out. These are empty lines. Okay. And I want to run these things in bash. So this environment variable is being expanded, and then this is prepended, and then this environment variable is being set. And then I'm going to list all of these environment variables. So that's echo $path. Maybe that's not a good idea. Let's do it the way it's documented in here. So it says that we should take the existing content of the prefix.sh file, which we did. And then in here, it's documented that we can prepend to the existing environment variable, in this case to the environment variable path, like this. We can prepend values to it by using the syntax equals plus. So that's why we're saying path, which is Qt creator syntax, and then equals plus, which is also Qt creator syntax, and says that it's going to prepend the variable, the value to the variable. And then we're prepending this part, which is before the colon. Let's do it like this. So we don't need the export space part. The equals needs to become equals plus. And we're deleting the part where it tries to expand existing environment variables. I'm not sure if Qt Creator has such a syntax for expanding environment variables. This is the syntax that works in the command line shell bash. Okay. This is the way it's documented in here. And it says that you should save the content of this file because it might come handy when you open another KD Git repository. The content will be identical. Control V, we paste it in here. And this should be it. There's no OK apply button. And now we can start running the application again. And this time we don't have the error message box for KIO, which we had previously. Okay, let's see if the application works as expected. Playback starts, we can see the progress. We can change the audio file. We can go back. We can change the way the progress in seconds is displayed. So might be how many seconds have passed from the start or how many seconds remain till the end of the audio file. Okay. Let's now go to the debugger and see if debugging works correctly. I'm going to press the escape key. So let's try the debugger. In edit mode, Control 2, this button. This is the tree view that shows the CMake structure of the Juke Git repository. So there's a top level CMake lists.txt file, and then executable target Juke, another executable target tag guesser test, and then additional CMake targets for images, documentation, etc. We could use this projects view, or we can switch to the more familiar file system view. This shows the source directory, not the build directory, which is what we want. And now we need to hunt for the entry point of the Juke executable. So the entry point would be, because it's a C++ application, a main free function. The executable's entry point is in the file with the same name, so juke.cpp, the same name as the project. Let's find in here the main. So there's a just a class in here. Let me search for the entry point. there's this file main.cpp, which just includes the entry point, so the free function, C++ function main, int main argc argv. I'll put a breakpoint on the first line where the debugger hopefully can stop if the application has been built using debug symbols. Let's actually check that. So that's kate, and then we have a configuration file for kdesrc-build. And the CMake build configuration, build type is debug, which means as little optimization as possible, which is probably -OG. And then debug symbols should exist inside of the ELF files, so not stripped. Okay, at this point we can actually start the debugger. This is notifying me that I have some breakpoints set way in the past, and those breakpoints are of type QML source code, not C++ source code. Okay, and that's what we get when we start the debugger. We're stopped at the correct place. Let's switch to let's look at the debug windows. We can, for instance, collapse the left sidebar, which shows either the file system structure or the project structure, and then open documents in this case. It's the same tree view shown twice. At the right-hand side, we have the tool window with expressions. So these are expressions that I have watched previously. So let's remove this thing. Remove all expression evaluators. Yes. Okay. Do we have on hover debug inspectors? Yes, we do. Says that there's one argument. Then does it have visualizers for arrays of chars or for arrays of strings of C style buffer strings? Zero terminated? Yes, it does. So the only command line argument is the full path to the executable, which means there are actually 0 command line parameters to the command line, which is the full path to this executable. Okay. This executable is running from the CMake build directory. In there, there's a so tilde/kd/build/juke is the CMake build directory. In there, there's a bin directory, and in there, there's this juke executable. So we didn't actually run the install step, just the CMake configure step and the build step. Okay, let's see if we can step into Qt source code. How do we do that? We have the buttons in here. Step into. And no, we cannot, because we've installed Qt 6.8.0 using the Qt Online installer without source code. So we just installed the SO files, the shared libraries, and the other files which are needed at runtime, maybe not the debug symbol files and maybe not the source code files. Instead, it stopped in a kdgit repository's source code, which we've built previously, which is named K internationalization KI18N. Okay, let's see how we get out of there. I'm not exactly sure where we are. Let's look at the at the call stack. So this is the switcher of threads. We're on the first thread, the main graphical user interface thread. That's done from the Qt Creator main menu, view, views, and then we want stack. We also want breakpoints. Let's remove all of the old breakpoints from the previous sessions from maybe months ago. Control A, delete. Let's go back to the main and insert the breakpoint again. So we put the breakpoint again on line 35 and we only have one breakpoint set. We're looking at the call stack. We're on line main.cpp line 35. And then from inside there, there's the constructor of Q application and a ton of other method calls and constructor calls, etc., function calls inside the Qt framework. So we'll probably need to put a breakpoint in here, and we're going to say continue, so get out of the depths of the line 35 and get to the line 36. And it respected my wish. So all of these things are using the GNU C++ toolchain, so G++ for compiling, and for debugging it's using the GNU debugger, GDB. And Qt Creator is manipulating GDB using its automation wrappers, probably the Python API to the running GDB instance. Sometimes this automation doesn't work perfectly. You probably need to close the processes, debug the application, GDB, Qt Creator, and then start from scratch. But while it works, we certainly can be happy that it works correctly. Okay, so we did not have the source code to Q application. We have access to its headers, so to the include files. Q application, which is installed in tilde/Qt with an uppercase Q using the Qt-align installer. So the header files are available because otherwise the G++ will not be able to compile. The integrated development environment also sees the header files. And that means that navigation works correctly. Navigation, you can navigate with Control-click on a symbol. And maybe there's also a context menu and other ways of navigating without control-clicking. Follow symbol under cursor F2. F2. So this provides you half of the go-to functionality. So because it's the C++ programming language, there's this split between CPP files and .h files. In the .h files, in the included files, in the header files, you have the public symbol definitions. And then in the CPP file, you might have private symbol definitions and the implementations. In the .h files, you also have implementations of C++ templates. But usually navigation to CPP files does not work. So if you control-click here and then you say there's usually a button to switch between the header and the CPP file, that will not work. So F4 switch header source will not work for include files which are not part of the current project that's loaded in the integrated development environment Qt Creator. So in this case, the Qt source code and also the KD frameworks K internationalization source code. So if I go control click on the K localized string, it takes me to the H file. That's mandatory and most of the time works, and mandatory for building. But it doesn't know how to switch to the corresponding CPP file, although I have the corresponding CPP file on my hard disk, although the CPP file has been used in order to build this .h file, or to at least install this .h file. Like this. So it goes through to an, I'm not exactly sure where. But then the debugger always knows the full path to the CPP file that has been used in order to generate the debug symbols, which are inserted inside of the ELF file, which is the shared library SO file or the executable. So Juke in this case, the executable, or the shared libraries for, I don't know what this thing is, Q application, Q widgets.so probably, and then this thing which is KI18NSO or something, KF. The debugger, navigating in the debugger is a bit better because the debugger can navigate to CPP files. So it's worse when you navigate using just the integrated development environment, because in the CPP files that are not part of this project, you will have a hard time navigating to, whereas the debugger has no problem navigating to all of the CPP files that have been used to build parts of the executable that's currently running. So it will certainly know how to navigate to the CPP file where this method is implemented. So let's actually make use of the fact that we're inside the debugger and navigate to the CPP file of set application domain. We do that by stepping into this button. Step into. Let's look at the shortcuts that are currently in place. Step into F11, so similar to Visual Studio and Visual Studio Code. F5 to continue and start. Step over F10, step into F11, step out, Shift F11. So step into. Okay, so now we're inside the CPP file, klocalized string.cpp, from the framework K internationalization. We can put a breakpoint in here. And next time when we restart the debugging, stop debugging and start debugging. And then we go run to until the next breakpoint. So continue. And then continue again. It will stop on line 1176 from localized string.cpp, from the correct place where I have the git clone of the K internationalization KD Git repository. Then let's look at one more thing inside of Qt Creator, which is, does Qt Creator have visualizers during the debugger for Qt specific C++ types, so for QString and other types? Let's see how do we do that. So domain is Q byte array, so a C++ type from the Qt framework. And we can see that the visualizers work okay. So I hovered on top of domain and it says it's a Q byte array, so one of the types for strings that are used when you program using the Qt framework. There's, I know, at least 5 types for strings in Qt. And the visualizer works because we can see that the content is JUK. And it also shows it as an array of chars, which is, I'm not sure if it's null terminated. And also says length 3. So it extracts more useful information out of the Q byte array type. Let's see if we can navigate to that type. So control click on domain. It goes to the definition of set application domain, the current method that we stopped in the debugger. Q byte array navigates correctly to the .h include file. And then it's using the pimple, the D pointer. There's an enum in here. And let's see if the storage is null terminated or not. How do we do that? So there's a size. We don't have access to the source code to the CPP file from of this type, Q byte array, so we don't really know what resize does. We can see that is empty goes to size, and size is an inline function which has the body inside of the include file. That's why we can see it inside of the .h file. So it goes to the D pointer and then looks at the size in there. Let's see what else it's on inside the data pointer. Q byte array data. Okay, what is this? Q array data pointer of char, which is what? There's this PTR, which is probably also a pimple. Okay, let's ignore that. So we can see that not all C++ integrated development environments have visualizers for the Qt types. This is actually important for me because I use the debugger a lot. And without it, many local variables, member variables, function arguments, I cannot actually visualize. Okay, so we're done with debugging in Qt Creator. We saw how to open a C++ project, which is complex, and it's using CMake, and it has other dependencies. We know how to edit the source code. You go to Edit, you go to Show Left, sidebar Alt 0. You can navigate either if you look at your project as a structure of CMake targets, or you can use the file system, so it's view which is similar if you use, for instance, Visual Studio Code or other more text-centric text editors. Right now it's showing me the full path of this localized string, localized string.cpp file from a dependency of jukes. Okay, and now it navigates back to tilde/kd/src/juk, where the juk.kd git repository is git cloned. There's no classic tabs for the open files. There's this combo box instead, And then additionally, there's this tool window, the Open Documents tool window. You can have more than one Open Documents tool window. You can transform the top tool window into such a tool window, like this. Let's see what class view is. Yeah, and amenities that you might be accustomed to when using integrated development environments. So at least viewing the source of the structure of the file. You can have it like this in the class view. You can have it in outline. You can have it in this combo box that's at the top of the text editor. And then there's auto completion, and we saw navigating to source code. Build errors. This is a build. So this is an incremental build, not a rebuild. That's why it's not showing the build warnings that have been detected when we have run CMake configure again and then a rebuild of the project. Okay, let's put this thing to the side and let's try to do the same thing with the other integrated development environment, CLion. It automatically opens the previously open project. Let's close that. File, close project. And now it shows the open wizard, the project open wizard. My wiki page shows how you install CLion. So again, we've installed it by downloading the toolbox. Then we're extracting the toolbox and we're running the toolbox. And from there, the toolbox knows how to install itself, how to update itself, how to list the installable products from JetBrains, because JetBrains Toolbox is an app store. Okay, we have started. The first time that you run CLion, it will ask you about a license because the CLion product is not gratis. You need a valid license. There's various licenses that you can purchase. There's, I know, monthly subscription, yearly subscription. You might get a discount if you're a student, if you're an individual developer. Maybe you get very cheap or maybe free licenses if you're an open source project, or if you're in a coding bootcamp, etc. So do look at the pricing information. This thing. Okay. And now we're trying to open a KDE project in CLion. We have in kdesrc-build RC set this thing we saw previously, which means that there exist build symbols inside of the executable files and the shared libraries, not stripped. We've built using kdesrc-build a Git repository, not kcalc but juk. We have access to this part of the output, or not. Okay, so let's follow these instructions. How do we alt backspace? Control Shift V, home, Control right arrow. In here we put juk. So what this does, kdesrc-build space juk builds all of the other KDE Git repositories that are needed, such that you can build such that it can build the Juke KD Git repository. And now we're telling it, please don't build any other Git repositories, but the Juke one. And then refresh build means build everything from scratch, because we need to see the full output. So debug means that it's not going to show this short of an output for the Juke project, but instead it's going to show 100 screenfuls of console text. No SRC means that it should not do git clone operations or other git fetch operations. Okay, we can stop the build now. We stop it when the first step runs, which is the CMake configure step, because we need this block. Like this, running CMake. So starting with running CMake and ending with from directory. Control V. Okay. And then using this output, we're going to feed the file open project functionality in the JetBrains CLion integrated development environment. Okay, so we want to open an existing project. That's so tilde/kd/src/juke/cmakelist.txt open. I want to open it as a CMake project. Like this. Interactive lesson available. Okay, so it shows tips on startup. It might ask if you can trust the directory where the git clone has happened and its parent directory. Because when you run CMake configure or CMake build or you run the editor, maybe there's malicious source code, and that might, I know, delete existing files or install viruses on your computer or install ransomware or something. Okay, then we want the build directory, but for that we want to configure the project. Unfortunately, this project has been configured before, and CLion remembers the settings from the previous time that I have opened the Juke project in CLion. How do we do that? Not like this. Open as project. Well, it would have been nice if it asked, should we reconfigure fresh this project and not use the previous ways that you have opened the project Juke in the integrated development environment CLion. Let's see how we do that. In the source directory of the project Juke, so the place where the Juke project has been git cloned, I can see this hidden directory idea.idea, which is the hidden directory for the ID configurations for the JetBrains integrated development environments. I will delete this. Let's close the project and delete this directory. What's interesting is that I have run git GUI to see if I have unstaged changes, because the integrated development environment has created a subdirectory .idea, which means that all of the contents of that directory should appear as unstaged changes, but they don't appear. Why is that? Well, that's because the directory is git ignored. In here on the penultimate line of .gitignore file, line 30, .idea. So that means that somebody else in the KDE community might be using probably CLion to work on the Juke Git repository. So I'm going to delete the idea directory, Shift delete. I'm not putting the directory into the recycle bin, I'm deleting it outright. So open like this, open as project. And now it shows the wizard which helps you open a CMake project inside the CLion. Okay, then let's look in here. So we copied a part of the CMake configure output, and in there there's the part where it says the directory that's being used, so the CMake build directory, which is this one and this one. It's the same thing. So tilde/kd/build/juke. And we need to paste this in CLion in the build directory edit box. So I'm going to rename this thing to Juke CLion, like this. Okay. Then it says that we should look at the output, at the full CMake configure command line, and ignore the parts -b and -s, and paste the rest in the CMake options edit box. So let's do that. This is the CMake command line. We're ignoring CMake, which is the name of the executable, -b, which means the build directory. We've already specified the build directory, and -s, which is the source code directory, which we've already specified when we opened the CMake list.txt file as a project in CLion. So we only want this part. And this should be put in the edit box CMake options. Okay, so we did this. We did this. And now we need the environment variables, which means we need to get this line where it says setting environment variable. And we want to transform it like this. The environment variable, then an equal sign, and then this full value. So we do that by doing replacements. So string replacement in the text editor. I've selected the part that needs to disappear, Ctrl R, which is the shortcut for replacing file in this text editor kdcate. Other text editors might use, I don't know, Ctrl H for replacing, and we go replace all. And then this should become an equal sign, which is also set in here. So Ctrl R, tab, equals, and replace all. And that's it. This thing should be put inside of the environment. Let's make this dialog a bit larger. So environment colon. There's at the right hand side of the edit box a button with tooltip edit environment variables, shift enter, this guy. And then we need to click the button with the tooltip paste, which is this guy. Okay. Okay. And we don't need to delete the CMake build directory because this directory does not exist yet. So it's not tilde/kd/build/juke, but tilde/kd/build/juke underscore CLion. Next up, in the bottom left, there's this button with tooltip CMake. It has run CMake configuration automatically for me into the correct directory, build directory, CMake build directory. But let's actually see it running ourselves. There's this clear all button. And then I'm going to run the reload CMake project button, which is this button. Reload CMake project. Let's see if the CMake configure step is correct. Installing it tilde/kd/usr, okay. tilde/kd/build/juke CLion, correct. It has found the correct dependencies, Qt, KD, non-Qt and KD, so free type font config, phonon is from the KD community, and taglib. Everything seems okay. We can build. So the CLion main menu, build, rebuild. And we can rebuild all of the build or the CMake targets or just juke. We can see that the CMake target selector is here. There's juke, which is an executable, and there's also debugger test, which is also an executable. We can build juke. So let's see what it says. Build, rebuild, juke. You can go rebuild all. Okay, 79 translation units and other things to do by Ninja. The clean step and then the build step. We can see the full command line that's being run. So it's CMake build, as we would expect. But then it's using CMake, which is from the CLion install directory, not from /usr, so not from my Linux operating system. And then the build directory ---- build, as I would expect. And then target juke, as I would expect, and then -J14. I'm not sure what this thing is. Maybe I have it in the configuration file. Let's see that. I have 16 in here, so I'm not sure where that 14 comes from. I have 16 CPU threads. And also the output is not complete from CMake build. It's only showing the warning, so 48 out of 79, and then the final linking. But it's okay. So this means that we managed to build. Let's see how we can run the application now. Run edit configurations, this guy. So CLion main menu, run. Edit configurations. Juke, correct. Environment variables. Where are you? This guy. The button, the similar button. Okay. I'm not sure if the block is okay. Maybe we want the block from here. So this is the block from CMake configure step, which was handled by kdesrc-build. And there's a different block in here in the prefix.sh file. We probably can get away with the same block used everywhere. But the safer option is to actually open the prefix.sh file, look at it, and then make sure these exact values for the environment variables are being set inside of CLion run. So we're in here, Ctrl-C, new, Ctrl-V, remove the lines that don't do anything, and then do some echoes. Ctrl-X, VVV, Ctrl-C, Ctrl-C, so Qt, QML, Qt Quick, and two more. Sassel path. Okay, let's run this thing in Bash in a new tab in a console. Kind of ugly. Like this. Okay, so this is where I am. I'm using the same block that's inside of prefix.sh to set some environment variables. And then I'm going to extract from Bash the value of those environment variables. It's this block. So I need this part. The reason is because we want something to extract correctly, to expand correctly these things. Okay, Ctrl-V looks like this. And then this thing we can probably paste in here. Ctrl-A, Ctrl-C, and this button with tooltip paste. Okay, executable juke, no arguments. Hopefully it runs from, I'm not sure which working directory. So this should be it. Now running from CLion should work correctly. The buttons for running are this guy. run without debugging, run juke shift F10. And it starts exactly the same way that the application started when we started it from the other integrated development environment from Qt Creator. Playback works. Previous. Play. Back to playlist. Everything seems to work correctly. Okay, let's now look at the way we can use the debugger. So we did this part. We want to debug. So from this tool window, the project, Alt-1, we want to search for the main.cpp file. Expand once. There's two directories in here, the git clone directory, /kd/src/juke, the CMake build directory, /kd/build/juke_CLion. And top level in here, in the git clone directory, should be main.cpp, which is this guy. Okay, let's see where we can see the symbols that are that exist in this file. I'm not sure how to get there. Hierarchy. Nope. Structure. Yes. Structure. Put a breakpoint on the first possible line, line 35. Let's start the debugger. This button debug juke in the main toolbar of the integrated development environment, shift F9, or from the main menu, run, and then debug juke, shift F9. The same thing, the same technology as Qt Creator. The executable is being built using C with the C++ compiler from the GNU project, G++, which is enclosed in Ninja, which is triggered by CMake, and the debug symbols exist inside of the generated binaries, inside of the ELF files, so shared objects.so files or the executable juke. And the process with the executable, the full path of the executable juke is being started and run inside the GNU debugger GDB. You can see in here we have access to the GDB REPL, read evaluation prompt loop, print loop. The same executable has been started, so from the CMake build directory, subdirectory bin, and then there's a juke executable there. So the CMake install step was not run, just the CMake configure and then CMake build. There's a tool window for the local variables, for the locals. So there's argc, which is 1, argv, which is an array of char, which is the full path to the executable. And the call stack is here, and the threads are here. Let's see if we can step into the Qt source code that we don't have access to the Qt framework source code. Step into is F7. Correctly, it did not find the source code there, so it advanced to the next line, which is line 36. Let's step into here. We have the CPP files on my hard disk for this method set application domain. So it knows how to go there. We can put a breakpoint, stop the debugging, run debug juke, stops at the first breakpoint. We tell it to advance until the next breakpoint, resume program F9. Where is it? There's run, and then we actually want go to the next breakpoint. Which is probably this one, resume program F9. Okay, goes to the second breakpoint. There we only have 2 breakpoints. And stops there correctly, line 1176. Let's see if we have visualizers for Qt style C++ types. For this guy, it shows a help tool window. So says that domain is a parameter to the local method, current method. Says the type is const qbyte array ref, which is correct. Okay, but I don't want that. I want to actually see the value of domain. Press the wrong button. Step over. Step over. Okay, domain was already presented into the locals tool window. It's in here. It doesn't immediately show that it's a Qt type. It didn't immediately say its length and its view as a string. But still, there's good enough support in here because it shows the D pointer, D. I'm not sure why it doesn't show the value of the symbol when I hover on top of it. It shows documentation. It would be normal to show the documentation on hover when the debugger is not running, but when the debugger is running, the tooltips should show primarily the value. Okay, the file does not belong to any project. How do we close this thing? I don't know. Okay, let's step over and get back to main. We can see in the call stack that there's only 2 functions in the call stack. The bottommost is the first one, which is main. Topmost is the newest one, which is set application domain. When we exit set application domain, we will get back to main.cpp. So step over. And now we're on line 38 to 42, which is the invocation of the constructor of the class kAboutData. Let's see how it's how the debugger is going through the various parameters in here. So step over, step over, step over, step over, step over. So it gives you the opportunity of getting to one of the arguments which gets converted from, I don't know, from qlat in one string constructor of the empty string 0 terminated C style to the actual object of type QString. and then you can step into and look at the actual .h file in this case. For the Qt framework, we did not build Qt framework from source, so there's no CPP files. But for the most of the other source code from the other KD Git repositories would actually get cloned locally and built from scratch using the build framework kdesrc-build. So we can step into CPP files for those. We cannot step into CPP files for the Qt framework. Step over. Step into Qt framework. Step into Qt framework. And let's see what's part of the Qt framework and what's part of the KD. So step into. Step into. It goes into the Qt framework's header files. Step out once. Step out once. And step into again. Step out. Step in. And finally, we're inside this what's this? A free function, C++, internationalization, which has as argument a const chart pointer, which is a zero terminated C style UTF-8 string, hopefully. And returns a Q string. We can inspect the text. When I hover on top of it, it doesn't show the documentation anymore. Now it's actually inspecting the parameter text. Oh. I don't know the shortcuts here. Step over. And step over once again. I like it when the integrated development environment shows me the return values of functions such that I don't need to inspect this thing or step into this thing or create a local temporary variable just to see what does this thing return. Okay, step over and step in. Step out. I wanted it to enter add author from key about data and I did not manage. We cannot navigate to the CPP file, so we cannot put a breakpoint there. But with a dance of step in to step out, I managed to enter the CPP files for the CPP file for add author, so the actual implementation of the method add author. So that would be step over, step in, out. So that's QString constructor. Step in, out. That's QString constructor. Step in. This is the key internationalization method I18N. Step out. Step in, step out. And now we should, because there's two I18N function calls. And now step into should go to add credit. And it does. So without this dance of stepping into, you cannot actually get to the CPP files which are outside of your current project that's open in the integrated development environment CLion. So to files which are outside of tilde/kd/src/juke and outside of tilde/kd/build/juke_CLion. Okay, and now let's see. Step over and inspect all of these. Not like this. Not name. Yeah, this is okay for me. Is enough. So it doesn't immediately show in here the human readable version of the value of the name parameter of the current method. But if you expand the D pointer, the pimple, you get to PTR, which is of type Unicode, whatever, char 16-bit key pointer, and this is shown correctly as UTF-8 string literal, and then it says that the size is 11. This is good enough. If QString is shown correctly inside of the debugger, inside of the integrated development environment, then that's 90% of the variables of Qt type that I actually inspect inside of the debugger. So if there's viewers inside of the integrated development environments debugger for all of the most common Qt string types, then C++ types, then that's enough for me. So great. So the debugger works exactly as we expected it. Great job. Stop the debugging, and now let's use the two integrated development environments at once. Let's see if this thing actually works. So in project Alt1, which is edit mode Control 2, we can, let's see how is this thing shown. So this is shown as multiple directories, including the includes. And here, this other one. The projects. And then there's also the include hierarchies. How do we do that? This. But this is for the current file. I'm not sure what this thing is. How do I close it now? Ah, synchronize with editor this button. Yeah, interesting view. This thing. Okay. Escape to close unneeded tool windows. How do we close this guy? Shift escape hide. Okay. So let's go to juke.cpp. Isn't there a search button in here? Probably is. Let's see if keyboard navigation works. JU, okay. Okay, juke.cpp. Let's close all the other tabs. Close other tabs, right click. How do we close the other tabs? Close all except juke.cpp. Great. Let's look at the hierarchy. This guy. and this guy structure, new class view. So let's compare the class view tool window to the structure tool window. Juke is a what? A class. There's no namespaces in here. Interesting. How do we get to the constructor of Juke? Sure, how? How do we get at constructor of Juke? At this thing. File handle. Wow, showing some random file in here. Maybe I don't understand what the class view does. So I want this thing, this combo box, but displayed as a tool window. With this constructor. How do I do that? Show subprojects. I don't understand you. Get out of here. Okay, so we'll use the combo box because that's what we have. Okay, how do we get at the what? At the read config thing? Are they sorted alphabetically? Nope, that's a problem. How do we sort them alphabetically? Okay, it's showing some Git history information. Function can be made const. So it's showing hints and fixes. There's in CLion 30 warnings, 14 weak warnings, and 11 text issues. So we can start fixing issues immediately. There's also issues presented in the scroll bar, in the minimap, and also there's issues presenting in the minimap of the text editor in Qt Creator. Let's go there. Right click, scroll here. This is the window style. Way of going to a certain place in a scroll bar. So right click, scroll here. And in CLion, it goes exactly where you click in the scroll bar. So it doesn't go one page up, it goes straight to the place where you clicked on the scroll bar. Let's click here and see what's it saying. It says that Qt is unused and Qcore application is not used. What does this thing say? File not found, UI tag guesser config DL dialog widget.h. Oh, maybe CLangD doesn't understand the meta object compiler, the UIC user interface compiler, and the RCC generator tools from executables from the Qt framework perfectly. Included header is not used directly. whereas this one says it might not be used at all. Let's look at the text issues. How do we do that? F2 goes through the next error. Let's see that. F2. What's the problem here? Something with copying. Pass by value and use std move. I have no clue what's trying to say, because this was state of the art 10 years ago to go const ref. If you do not want to modify this thing, so if you want this thing to the first parameter to be in parameter, not in out parameter, then it's good practice to go const and ref on it. But now it's not good enough. Now you must use std move, because that's what CLion ID says, which I'm not exactly sure what that thing is. Okay. CLion type. The value returned by this function should not be disregarded. Neglecting it may lead to errors. So connect is actually a what? It's a function or whatever. What is it exactly? So connect is a member of a Q meta object, of Q object, and all Qt classes, including probably this one, inherits from Q object. Like this. Control W should work, otherwise I totally don't like it. I don't like Control F4. And Control F4 doesn't even work. So some of the shortcuts that I always use in all of my IDEs, I use Visual Studio Style shortcuts, and especially these ones. I want Control W to close the current tool, the current editor tab. I want Alt Backspace to navigate backwards. Bonus points if Ctrl-Shift-H is replacing all files, Ctrl-Shift-F is finding all files. If F4 goes to the next issue, or to the next issue, like that, in a tool window with issues. Probably F7 build, F5 run with debugger, F10, F11, Shift F11 for step in to step out. And Control S to save. I want a easy access to the save all button, either put it in the toolbar or have a shortcut, or file save all this action. Control S. Control S is file save all. That's an improvement over file save, so which only saves the current file that's opening the current editor tab, to have the shortcut Control S. Okay, middle click, which is the clicking on the scroll button on the mouse, should close the tab. So similar to what's available in web browsers. So then connect is this.connect probably. So connect is a member of the current object. This thing is a nice feature where at the top of the text editor, a few lines are showing how indented you are. So if you're inside of a namespace, and they're inside of the namespace, you're inside of a class, and then you're inside of a method, you know those things. Like this in here, it says that you're inside if first run inside of the constructor for Juke. Listing line 102 and line 82. Okay, what's this? The allocated memory is leaked. Warnings are not true because Qt uses parenting. So if a menu has as child a menu item, when you close the menu, when you free the menu, it will go through all of its children objects and free all of the menu items. So there's some friction between CLang, CLangD, CLangTidy, and the various IDEs and the Qt framework. The value returned by this function should not be disregarded, and it returns a QMeta object connection. And you don't have access to the CPP file that's behind QObject.h, so probably QObject.cpp, so we don't get to see how this return type is being returned. But it's perfectly valid not to need a return type. Because this is not a query, it's a command. So this does what you want, which is you want to connect a signal to a slot. You don't actually want to get back something and then act on it. So probably this warning should be, I don't know, ignored or ignorable, but only for the connect methods. Okay, what's this issue? Allocated memory is leaked, not true. What does it say about reply? Reply can be moved to inner scope. Reply can be moved to inside the then block. Yeah, do that. And it does it correctly. And then it says join declaration and assignment, which is of course what you would want. So systyle is to have some type declarations at the start of the block. Just like that, because I know you grew up with the Microsoft style of the C programming language, or with the Turbo Pascal programming languages. But otherwise, the declaration should be as close to the usage as possible. Move. And where are you? Join. Okay, I don't use the functionality for Git in any integrated development environment. Where is Git in here? I don't even know. I use the graphical user interface applications from the Git project, which is git-gui and git-k. And I would want a terminal. Let's see if that exists. It goes to this interesting directory. I'm not sure why, because the only opened file text editor is inside of the source directory. And in this tree view with project, I'm also inside of the source directory, so I'm not sure why it preferred to go to the CMake build directory by default. Let's see, like this. Yeah. Well, I can create a new tab. Ctrl-Shift-T should be, and it is. And then I can change it to this directory if I can copy the directory. Ooh. How do I paste? Copy path reference. Ctrl-V. Right click, copy path reference. Oh, like this. It shows a sub copy path reference. Okay, and now I want the nothing. The absolute path. Ctrl-Shift-V, Alt backspace. Okay, and in here I can use the graphical user interface tools from the Git project. I don't like this type of indentation, which has random indentation. So in here it's like this, and previously it used to be like this. Okay, what else do I want from a perfect text editor? This thing is really interesting. So we go project errors, inspect code, whole project, analyze. So it's doing static analysis of files of type C++ programming language, or files of type C programming language, of types of files of type markdown, text, plain text, I know, XMLs, JSONs. It's using CMake linters, tools from the CLion project, etc. Proofreading text using dictionaries. The typos are usually not an issue. They're just identifiers and module names. In here it says that the line numbers, so numbered lists in markdown type, could be like this. So you have just one dot and one dot, or it's even better if you go one dot and then two dot. So this should be a 2. The embedded browser is suspended. The system restricts the embedded browser from running with the sandbox enabled. Corresponding AppArmor profile must be installed to start the browser sandbox. I know, disable sandbox. Background tasks are running. Yes. So I'm on a Linux operating system in the family of Ubuntu. In here, there's AppArmor installed by default, and the embedded web browser that's shown inside the CLion is using the Google Chromium web browser engine from the Google Chrome project. And this prefers to run with as few privileges as possible in order not to create security issues. So it wants to run sandbox, but in order to be able to run sandbox, you need to have AppArmor, and I do. And then you need to have a configuration file for AppArmor for the Chromium web GUI control that's shown inside of CLion. So I just told it, don't install any AppArmor profile, because that would probably require elevation and might remain on the system even if I uninstall CLion. So I just told it, it's okay if you run the Chromium web browser engine graphical user interface control, not sandboxed inside CLion. It restarted CLion, the application. Okay, let's inspect the code one more time. So if you ignore the inspection results proofreading typo and some of the issues which are false positives from the CLion project because we're using Qt and the KD projects are complex projects with many dependencies. Then if you inspect the remaining list of issues found by this inspector, there's possibilities of doing very small Git commits that actually also require a small amount of time to make sure that they're correct, that they make sense, and that they move the source project in a positive direction. In this case, it's an open source project, so you can make easily contributions to this open source project. So for instance, in this case, you could replace this one with a 2 and do git commit. Let's see what CMake has. Subdirs is deprecated because the let's see what the version of CMake is. So in the top level source directory, there's a CMake list.txt file. This specifies, so this is the entry point to the CMake configuration files. This specifies the minimum CMake version that's required, which is 3.16. And then if the recommended replacement for this deprecated subdirs command works on version 3.16 of CMake, then you might study and replace subdirs with something else. Add subdir directory, add subdirectory. Most of these issues do require upfront investigation. So some of these you should investigate, but do them in a time-boxed manner. Like, don't lose more than half an hour to actually investigate the issue thoroughly, because there are other issues which you might be able to thoroughly investigate in less than half an hour. So time-boxed, invest 30 minutes to find out how to fix the issue and if you should fix it. And if 30 minutes are not enough, then you go to the next issue or warning from this huge list. Let's see, an issue not of type grammar typo, but of type grammar proofreading. Set up the menu which handles the random play options. So setup is a subject and set up is a verb. So you should use a verb, not a noun in here. Put a space in here and do a git commit. Okay, so this covers everything, how to install the two integrated development environments, how to load inside the integrated environment a complex C++ project using CMake, how to CMake configure, how to configure running with the correct environment variables, how to run inside of the debugger, how to use the debugger step in to inspect variables, put breakpoints, inspect symbols of type C++ from the Qt framework, such as a QString or a QByte array. How to look at the structure of a file, how to close all other files, how to navigate files, how to find all of the issues, static analysis type using CLion. What else? How to navigate to source code when you're not inside of the debugger, when the debugger is not running. How to navigate to CPP files during the debugger session by going step in to step out multiple times. And from here on, if you know how to use the integrated development environments, you have opened the correct source code repository in it. You have done all of these things. From here on, you just need to use the debugger some more such that you can learn the source code, run the application inside of the debugger, see what the events on the GUI controls do, see how saving is done in this case for a audio player application, see how the model behind the playlist list view is structured, and get the feel for the project. And then you will be able to fix issues that are described in the issue tracker for the project, or maybe you will just fix compiler warnings or issues found by other static analysis tools such as PVS Studio, CLion, the CPP check tool, the CMake linter, and the linters for XML, JSON, Markdown, etc. Thank you.